So hi guys, fourth mailbag, and I seem to have quite a bit kicking around here. Although there are a lot of packages, probably they only relate to a couple of different projects and things that I'm doing at the moment. So let's get started. Let's put this out of the way. I'll get started with this pile here. So these are all from CPC. Okay, cool. So in here, mainly just some ferrites. There's a couple of other things, I guess. I'm just trying to find my remote control so I can zoom in. By the way, if you see the computer screen changing a lot in the background, that's because it's going through a repair. Thank you so much, Microsft, for... Oh, well, that's not going to work. For screwing up my computer last time you did an update. I just get blue screen of death as soon as it starts now. Anyway, here we go. So I have some ferrite beads here. So these clip round cables, and an FT01634 is the part number from CPC, and these are 4mm core ferrites, which I got to work on the project that I'm doing for some current sensing. Now, on reflection, I think these might be a little bit small. These have got a 4mm core. The problem is I'm a bit worried that I won't be able to grind enough away for the recess. Anyway, for this sensor, but there we go. These are some... It's got the CPC code on it, which is a real pain. I wish they put a proper label on. These are TL072CPs, so Op Amps. And these are DIP packages. And this is because when I was doing the prototyping on the current sensor, I realised I hadn't got very many of these in stock, and they're a very, very useful IC indeed. So basically it's a low noise JFET front end op amp. So it ticks all the boxes really. It's, you know, not a huge wonderful input offset or anything like that, but you know, as a general purpose op amp, it ticks the box. So there were stock problems, it has to be said, when I placed my order with CPC. Yep, so here's the evidence of that. Yet another packet of ICs, and these are TL072IPs. So they're essentially the same as these, apart from these are CPs and these are IP. These are consumers, so I think they're 0 to 80 is the, or 0 to 70 is the temperature range that these are rated for, and these are -40 to 85, I think is the range. So they're basically the same thing. So I've popped some of the ferrites out of the little holder so we can see their actual size. So they are only, where's my ruler? So they're about 9.5mm long, similar sort of width across the outside, and then a 4mm bore through the center, although truthfully it does look a bit more like 5mm from where I'm looking. But yeah, my fear is that I don't really have enough room for the sensor. I need to grind a little bit away from that thing. If they are right, then they'll be great. And CPC has these at about £1 each, whereas they're £3 odd on Farnells and not available on DigiKey. Anyway, more of that in a second, I think. Okay, so these are just more of those ferrite cores, and the reason is I ordered 10 and they could only supply 2, and this is the back order. Like I say, most of these are all the same thing really, or all relating to the same problem. So this is the last of the CPC packs. Bit more stuff in here. So there's a different set of cores, 1, 2, 3, 4, 5. So being a bit worried about the physical size of those first ones, I purchased some others. Now the actual cord is just unclipped from this piece of plastic. I'm just not going to do that at the minute. But they're quite long, and that's certainly a problem, because the length of this is the width of my current sensor. But my thought with these is that I could actually perhaps slice 2 out of each one of these, because these are 20mm long. So my thought was that as well as grinding, that I might actually cut these through the center, and that would just give me a bit more space for the current sense device to be slotted in. Anyway, we'll see what happens. Other thing is packs of trimmers. So these are all Bourne's, well, actually they're not all Bourne's trimmers. These are Bourne's trimmers, multi-turns. These are somebody else's 5K trimmers. And the reason I purchased them, there should be another bag of them actually. I'll have to have a look and see what's happening there. So the reason I bought these was because when I was going through my sort of tray of trimmers, just here, in fact they can be stocked straight away, that actually I found I didn't have any of the low values in multi-turns. So that was a bit of a drawback really. Okay, take a look at this guy. So it just made it more difficult to prototype when I didn't have appropriate values. Oh, okay, cool. So these are batteries. So AAA batteries. I don't know what you call them in other countries. LH somethings, LR somethings. LR03s, there we go. So let's just check the use by date on these. Do they have a use by date? It's fine for up to 10 years. Yeah, 2030. So these have actually been in stock then for 2 years already. So it's not particularly impressive. But in truth, these are not going to last me 8 years. I seem to go through them like water. My burglar alarm, for example, takes 3 of these per sensor. I have to change them about once a year, and there are 5 sensors. So yeah, so that's just the passive sensors. There are other sensors that take all the batteries, but yeah, 15 of those a year is a matter of course. I am actually going to try some rechargeables, and I'm hoping they're in the pack somewhere. I'm not going to test them. These are AAAs, but there should be some more batteries kicking around. I think this might be some, and the reason is a bit of a giveaway. Return address, Battery Group Limited. So I really, you know, plastic packaging nowadays. Really, come on, guys. So recently, I have been using lithium ion, i.e. lithium with Fe ion in it, but for most of my use I don't have that much current draw, so actually normal alkaline are probably, I mean, they're a quarter of the price, and they probably last for 60% as long. So yeah, they're, you know, price per watt, these are definitely better value for me. So I'm going to do a quick test of these. I think I've got a lithium energizer kicking around somewhere, and I'm going to put them both on discharge for about 24 to 48 hours, just see how they perform. So what I'll do is I'll look at the amp hour rating for them, and just try and just see how well they perform against each other, and also another battery as well. So that's them. Okay, and here we've got some more Panasonic batteries. These, however, are rechargeable, of course. And because I seem to be going through so many batteries, I thought I'd have a go at rechargeable. see how will they perform. Now, these are 1900 milliamp hours, these are 750 milliamp hours, these are triple A's, these are double A's, or AA's, and and I've got 8 of each just to try them out. And what I'm trying to hope for is that these will do a reasonably good job in burglar alarm sensors, in the mouse for my keyboard that goes with the keyboard, things like that. The mouse in particular seems to run out quite quickly, so I'm hoping to use these instead, and wherever I can. Now, of course, although 1900 sounds pretty good for milliamp hours for these, compared to a non-rechargeable version, of course it doesn't have as many watt hours because these are lower voltage, and these might trigger things like battery warning lights and things like that on some of the devices that I have. So yeah, we'll see what happens with that. You know, it's got 2 chances really. So anyway, the intention is to give these a go. I'm going to run a discharge test on these as well. So that'll be a separate little video. I'll do these and some the non-rechargeables and some energizers, I guess. Just see how they stack up. Now, one of my reasons for buying these is, in the past, I've had difficulty with rechargeables. They just self-discharge too quickly to be useful in low current situations. So I'm expecting these should stay charged for a year, and I'm hoping to get good usage out of these compared to these, which obviously these can last 10 years, these only last a year, but in truth in the device these are only going to last a year anyway. So fingers crossed these will be an economic solution. So that's why I bought them, because specifically, I mean, these got about 2,000 recharges, they come ready charged, and they're supposed to stay charged for about a year. Now it's actually sort of 80% after a year, but that's pretty good. So hopefully that's the end of it for batteries. What's this? Oh, okay, yeah. So, whoa. Oh, there we go. So this is a USB to RS232. I got this model here. This is a cheapo model. I don't want anything expensive, but this goes to quite a high data rate compared to some of the ones that you can get. I'll link it in down below. Right, anyway, so there we go. One USB to serial. In. Thank you very much. Not hugely long cable, but it's okay, it's fine for the job. Yeah, and so of course this should plug directly into the device. So why have I bought this? Well, because the PC I have under the desk here, one of the reasons I've got it is because it's got real serial ports, 2 of them. It's got real parallel ports, 1 of them, plus a plug-in parallel port. It's got a stack of USB ports, of course. Now, for my test gear, I run most of it using Ethernet. My fallback then, if I haven't got Ethernet, is that I run it on USB. But some of the older stuff doesn't have USB, and you need serial, real serial, not sort of this low voltage serial stuff that we tend to use nowadays, but actual serial with real serial voltages. So that's why I bought that, to because I'm suspecting that the PC in here is going to be going, and I'll have to bring in a laptop that I have elsewhere to use that instead. So anyway, there we go. Try that way up. Yep. So just a USB to RS232 DB9. This one really just it feels like there's nothing in it. What are they? Oh, okay. So these are OH49Es. So these are Hall Effect sensors. Now I was thinking about using these for my current sensor application. and I had ordered them for that purpose, and then I changed my mind and decided to go for something a little bit better. So these are quite a lot less sensitive than the version that I'm actually using in my prototype. They're perfectly all right, they do a perfectly good job, but the version, the prototype, for example, on this, the output shifts a little bit depending what voltage you operate it at, and the version that I'm using doesn't shift at all, so that saves me a regulator on every board, and yeah, all sorts of stuff like that. So anyway, they'll still be quite useful. I'm planning to use these. I think I got a lathe I want to sense the speed on, and I want to do some position sensing on some axes on a pick and place machine. So this will do all of that for me. Okay, envelope in an envelope. Very exciting. Oh, if only they hadn't glued that down, I could have reused that. Come on. Oh. Let's torn it. Okay, transistors, I think. Yeah, transistors. So these are some new old stock. These are 2SC3568, so they're like a medium power transistor. I think these are just bipolar. Nothing special about them really. I actually purchased these for repairing Spectrum Analyzer, and then I realised that they were going to take forever to arrive, so I bought some more locally, and these were cheap. I just left them on order. This is obviously a DigiKey parcel. I seem to have a lot of DigiKey parcels at the moment. I do use them quite a lot, but I also like to use Farnell if I can. But recently, Farnell's prices have somewhat escalated, and so the reason I got those things from CPC earlier, Farnell stocked them all, which isn't surprising because CPC is a subsidiary of Farnell. In fact, the order codes are the same. The prices, however, CPC for many things, not everything, many things, is a third of the price of Farnell. So there we go. What have we got here? So these are the power jacks for use on the current sensors. So let's take a quick look at those. And they are pretty small. Let's try and zoom in a bit. So these are normal barrel connector jacks, but they are pretty small. They are 5mm across the back, and they stand up, can't remember off the top of my head, 7mm I think off the board in total. So I'm kind of hoping I've got the right size. It feels like it is. But yeah, I had to kind of dig around and measure stuff and hope for the best, and that feels okay. But it's pretty small. It's a 1mm pin, 3 point something millimeters outer diameter on the barrel. So yeah. Oh yeah, these are the Hall Effect sensors for the actual prototypes. So I'm making 10 prototypes, and yeah, here they are. So the way the prototype's going to work is it will actually be manufactured in full with all the surface mount components at the factory. The case will be manufactured on kind of like a push-out grid, like a kit type grid, and so essentially you can kind of snap all the parts of the case off, put the assembled board in it, and clip it all together. The only thing that won't be soldered are the power connector that you just saw, the actual lead running out to the oscilloscope, and the actual sensor. And I'll be making a jig up so that we can bend the leads for these sensors so they drop straight in the right position. But I can't do that until I've got everything delivered on the prototypes. Okay, finally, last but not least, on the subject of current sensors. So I decided that I would give one of these a go. A couple of other people I know have given these a go and been pretty happy with them. For some of the stuff I do, this just isn't useful. This is physically too big, and I want multiple channels and things like that. But yeah, this is a current clamp. Let's take a quick look at this. So this guy is designed really to fit into an oscilloscope. Hence it has a BNC connector on the end. Okay, cool. Probably an auto zero, I guess. I did think about putting auto zero on the current clamps that I'm making. I didn't do it for the moment. I mean, it's not that difficult to do. You just need a sampling circuit, sample and hold circuit, to do the offsetting, and just use the feedback to tune it and then lock it into place when the button's released. So nothing hugely complicated about a sample and hold circuit. So I suppose the obvious question is, since I'm busy prototyping a bunch of current clamps, why do I need this one? Well, there's quite a bit of difference between the prototype and this one, and there are quite a few similarities as well. So difference wise, the prototype that I'm making is going to be about the size of this clothes peg, maybe an inch longer, something like that. But that's all. And it's intended for low current use. So in terms of output, it will be 1 millivolt per milliamp. So that's 1 volt per amp. This is slightly different. This has got 1 millivolt per 10 milliamps or 1 millivolt per 100 milliamps. So it's 10 times less sensitive or 100 times less sensitive, which makes it more useful if I want to measure higher currents, let's say 10, 20 amps or something like that. This is the guy for that. So that's one reason. The other reason is that this is physically larger at this end, so I can put, you know, bigger, more general purpose cables through it. And finally, is actually from the similarity point of view, this has a similar bandwidth and everything to the clamps that I'm making. This is a 20 kilohertz bandwidth, and guess what the bandwidth of the clamp is that I'm hoping to produce, which is about 20 kilohertz. So very similar in that sense. It feels all right. It's only 60 quid, and be about the same in dollars, I think. I was going to buy this from AliExpress, but I've had a few problems when they've delivered wrong parts and things like that. AliExpress have been absolute rubbish at resolving the issues, and I generally had to go to PayPal to resolve the issues instead of AliExpress. So I've kind of steered away from them a little bit. So I got this on Amazon. I'll put the link in down below. It'll be a bit weird with US and UK linkage and stuff maybe, but anyway, do the best I can. So yeah, I'm hoping this will work out okay. In terms of testing, I'm not going to do that now. This video has been running long enough. There'll be a video for the prototype current probes that I'm making. That's the plan. So when I do that video showing all that process, then I will probably do a test and we'll see this in use on that test as well. So anyway, that's enough. I think I've been going about 30 minutes. Hopefully after editing, it'll only be 15, but that'll do for today. Hopefully you enjoyed that. There's not a huge amount of parts here, really just a load of batteries that I'm going to do some tests on later. Some stuff for the current clamp, a few spares, and that's our lot. Usually it'd be a lot less packages, but with supply problems at the moment, you know, things are what they are. Anyway, hope you enjoyed that. If you did, please give it a thumbs up. Please subscribe if you haven't always, and that's really important because I do at some point need to get up to the point where I can monetize the channel, because I do self-fund all of this stuff at the moment, and that's one of the reasons the videos are coming out a bit slow as things stand. Anyway, please comments down below, subscribe, like, and I'll see you next time. Take care, have fun. Bye now.